Welcome everyone, I'm David Aboud. Today's webinar follows the complete development from discovery to production of a battery-powered memory game. In an era shaped by AI and seamless integrations, modern design tools enable scalable digital continuity across ecosystems to drive electronics design innovation. Let's dive into our real-world journey with Siemens Expedition, PartQuest, and partner integrations to learn more about how you can build your own modern design journey for you and your team. Before we dive in, I'd like to give a quick overview of what we'll be covering. Our agenda is designed to guide you through a modern design journey, from strategic alignment to hands-on innovation. First, we'll start with aligning technology to your priorities. Here, we'll discuss how you can ensure your technology investments directly support your organizational goals, maximizing both efficiency and long-term value. Next, we'll focus on optimizing battery life. We'll share best practices and advanced techniques for extending battery performance, which is critical in modern electronics. We then move to integrated PCB design. You'll see what true integration looks like when it comes to designing printed circuit boards, unifying schematic, layout, verification, and DFM into a seamless workflow. After that, we'll go through a design review, discussing how to streamline collaboration, reduce errors, and quickly validate design intent across your team. We'll also examine actionable DFM analysis, where we'll show you how to detect and address manufacturability issues early on in the development process, saving time and avoiding costly rework later in the lifecycle. Finally, we'll explore AI-assisted coding, where you'll discover how AI can accelerate your design process, enhance code reliability, and drive innovation. With that, let's get started with our first topic, aligning technology to your priorities. Design team priorities have never been clearer. Competitive companies want to reduce cost and shorten time to market, so they look for ways to accelerate productivity and enable real-time collaboration. As design complexity rises, some companies overspend on suites that they don't fully use. On the other end of the spectrum, companies turn to entry-level tools that turn into bottlenecks, introducing errors, slowing releases, and forcing painful, time-consuming upgrades. The key is finding a balance to the total cost of ownership as your design needs grow, by eliminating design inefficiencies, streamlining processes, and empowering smarter resource use. The proven Expedition technology stack combines intelligent automation with an integrated workflow and seamless collaboration across ECAD, MCAD, manufacturing, and component sourcing. Teams move faster with fewer handoffs and less rework, powered by integrated design data and real-time supply chain insights to de-risk decisions proactively. Flexible expansion options let you add design depth on demand so you can avoid overbuying and tool churn, while preserving a clear path to enterprise governance when policy or scale requires it. The result is enterprise-grade outcomes without the infrastructure setup, complexity, and maintenance. You can focus on the design process for shorter design cycles, higher first-pass success, and confidence that your team can take on tougher decisions without disrupting your workflow. When you're working on delivering design innovation for tomorrow's problems, it's critical to avoid cost without value. Expedition standard add-ons offer enhanced capabilities that you only pay for if you need them. Add-ons enable access to the entire suite of advanced tools through one flexible token pool, avoiding the cost and complexity of separate licenses. Borrow tokens from your shared pool and return them upon completion. Eliminate the need to purchase individual feature licenses by using a single token pack to access all advanced capabilities. You can unlock smarter workflows using tokens to activate industry-leading design capabilities. Today's products often span mechanical, electrical, electronics, and software, and teams need a way to bring these domains together without friction. To help you and your team focus on designing innovative products, Expedition takes care of the infrastructure behind the scenes so you don't have to live in the weeds. Siemens ensures data continuity and consistency in your product definition as you move from one phase to the next. What starts as a point tool quickly evolves into a digital thread, a strong foundation that grows with you and supports the broader journey to enterprise-level capability. Our approach offers true integration of the real and digital worlds across the entire product lifecycle. Expedition and the Siemens Xcelerator portfolio enable you to manage and connect every layer of information. For example, from company part numbers to 3D models, across processes, teams, and disciplines, making your digital transformation both practical and scalable. Ultimately, you get a robust connected backbone supporting your entire product lifecycle, freeing you up to focus on what you do best, designing world-class products. This leads to our final point on intelligence. Today, most engineering data goes unused. Not because it lacks value, but because traditional AI doesn't understand engineering. Large language models are powerful, but they're trained on general knowledge, not the realities of product design and manufacturing. This is where Siemens is different. We're teaching AI the actual language of engineering and manufacturing, connecting our direct experience in electrical, mechanical, simulation, manufacturing, BOM data, and more, with models that contain industry knowledge bases and industry best practices, as well as documentation. The result is AI that understands intent, not just geometry. It can assist with everything from industry-leading routing automation to AI-driven datasheet analysis, helping you make faster, more informed, and more resilient design decisions. Now, let's take a look at how we can bring together these technology standards for an integrated design workflow. By the end of this webinar, you'll experience how Expedition enables an integrated workflow to accelerate productivity and remove complexity barriers. We'll follow the full development of a battery-powered memory game, not just as a proof of concept, but as a repeatable workflow so you can start applying the next generation workflow immediately. Earlier, we discussed aligning our technology to priorities. The Siemens Expedition workflow allows us to be adaptable, integrated, and intelligent. These values hold true across the Siemens ecosystem and partner design tools. Let's take a look at some of the partner integrations we use for this design. We started off using AI to accelerate innovation by turning concepts into functional circuit architecture. In this case, we integrated Siemens, Microchip, and Celis tools into a unified design flow. We use PartQuest for web-based circuit simulation and real-time supply chain insights. This helps us prevent expensive redesigns, turning reactive workflows into proactive ones. We also use Siemens Connect for modern collaboration tools to connect engineers, procurement, and manufacturing. This isn't about replacing engineering expertise. It's about elevating it, amplifying your skill with AI-driven insights, zero-maintenance tools, and smarter collaboration. Let's now take a step into the design journey with a quick overview. Every design starts with an initial creative spark, an idea ignited by need and imagination. With AI-powered concept design tools, teams can rapidly transform ideas into design intent, leveraging automation right from the outset. From there, we move to schematic capture integration, Here, the design takes shape as we map the functional architecture into detailed schematics, ensuring every component and connection is accounted for, seamlessly combining speed and precision. Next, we focus on optimizing battery life, a growing demand for sustainable and efficient electronics. Embedded intelligence quickly analyzes and proposes circuit improvements, helping to maximize performance and energy efficiency with digital iterations. As we progress, design updates and supply chain intelligence come into play. Real-time insights integrate component availability and risk factors, empowering teams to make informed choices and avoid costly surprises downstream. The workflow continues into the physical board layout. At this stage, layout decisions directly impact manufacturability and performance. Our integrated environment ensures that routing, placement, and mechanical constraints are intelligently managed. AI-assisted coding further accelerates firmware and embedded software development, streamlining code generation, catching errors early, and keeping design iterations smooth and connected to hardware. Before finalizing, design review provides automated checks and team collaboration, bridging disciplines and ensuring every requirement is met. Automated verification reduces oversight and eliminates common bottlenecks, helping teams work smarter, not harder. Finally, manufacturability analysis ensures that every design can move to production confidently. Built-in DFM intelligence flags issues before fabrication, reducing costly rework and accelerating the path from prototype to market. Step by step, our digital approach transforms creative ideas into tested manufacturable products, enabling innovation, reducing barriers, and ensuring that every spark of inspiration becomes a real-world, sustainable solution. This is how Siemens empowers tomorrow's electronics today. Every design starts with an idea, requirements, and constraints. For our memory game, we needed a microcontroller to handle the game logic and a 3-volt lithium coin cell battery for power. This is all housed within a compact form factor that could fit comfortably in your hand. User interaction was key, so we incorporated LEDs as visual indicators to show which buttons to press and a buzzer to provide audio feedback. For the input method, mechanical buttons proved to be too expensive, so we chose cost-effective touch-sensitive buttons, which required adding a touch controller to the design. With these requirements defined, let's see how a partner integration with Celis helps us transform rough ideas into a functional starting point. Celis is an AI-powered platform that started to revolutionize early-stage circuit design. We can take our rough requirements and feed it to their design assistant to help us find the right components, the functional circuits that will give us a great starting point. Now, let's walk through how we use Celis to create the starting point for our memory game. We'll start by navigating to microchip.celis.ai. Once you create an account, we can go ahead and create a new project. When creating a new project, the first step is to configure your project settings. We need to provide some basic information, including a description of what we're building, and as we discussed earlier, we have a set of requirements for our memory game. We know we need 4 LED lights, a microcontroller, and a boost converter, so let's add this to our project summary. This helps the platform provide more accurate recommendations for our design. Once that's entered, we'll save and move on to the next step. The second step is to provide additional project information, such as the project name, the functionality, and the type of application for our memory game. For the type of application for the game, we select consumer electronics and proof of concept. We also need to configure our outputs by selecting our target CAD tool. We'll choose Siemens since we're using Expedition for our schematic capture. For the BOM type, we'll select Consolidated, then hit Save. The last step in the project settings is to specify any constraints. We'll select Microchip Technology as our preferred manufacturer. Now we can hit Select Template to proceed. The last step in the project settings is to specify any constraints. We'll select Microchip Technology as our preferred manufacturer. Now we hit Select Template to proceed. The platform provides templates that can be a good starting point for various designs. However, for this demonstration, we'll start with a blank canvas so we can go through the full process together. On the left-hand side, you'll see a library of predefined modules. Notice how we're already getting recommendations for microcontrollers. Switching to DC converters and standard LEDs. These suggestions are based on our project description. Each module represents a complete functional block that we can use to build our system architecture. Also on the left is the Design Assistant. We'll use this to start crafting our design. I'll start off by typing, I need an MCU powered by a coin cell battery with a buck boost converter. Watch as the Design Assistant places functional blocks on our canvas. Let's continue by adding, can you add 4 LED connectors to the microcontroller via GPIO? As you can see, more functional blocks were added to repeat our request. Now we can review the suggested architecture and adjust it as needed. I'll reposition these blocks and modify connections to better match our design intent. Once we're satisfied with the architecture, we can initiate the resolve process. This tells Celis to search for suitable circuit level implementations, which are called Kubos. Kubos are self-contained modules that include schematics, validated connections, and part specifications. You can think of them as proven circuit blocks extracted from reference designs and application notes. Let me click on a functional block to select the Kubo. For example, clicking on the switching DC to DC converter shows all matching Kubos. We can browse through the list to find one that best fits our design. I'll select MCP 16251 for our boost converter. I'll select MCP 16251 for our boost converter. Throughout this process, you can also use Kubo AI Assistant to ask questions about the design and evaluate different options. At any point, you can review the bill of materials. The BOM includes direct links to datasheets and component information. This is assuring you that all components are active and in stock before we even move into the schematic capture tool. When our design is complete, we proceed to downloading the outputs. This will provide PDF documentation containing the project description, the schematic, and the bill of material. We can also get a CSV file of the BOM and, most importantly, our EDA package. This will contain the schematic and component footprints needed to import into our schematic tool. Let's download this package and we'll import it into our schematic capture tool. Before we import the output files from Celis into our schematic tool, I want to take a moment and recap what we just saw. What would traditionally take a couple of hours, maybe days to go through, finalizing our component selection, finding reference designs and datasheets, Celis was able to quickly find the functional circuits that met our requirements. Now with Expedition open, let's create a new project by clicking on New. I'll name mine Microchip Masters 2025 Memory Game, and then I'll select the location where I want to save this. And once I've selected my location, I'll click OK. Now that we've created our project, let's go ahead and import the EDF output we got from Celis. To do that, we'll click on File, go to Import Other, and then we'll select Import EDF Schematic. We'll then browse to the output files from Celis and select the EDF file. Once we've done that, we can click OK and see the EDF file is being imported into our schematic. We can scroll all the way down to the bottom to see that our design was converted successfully, and then we can close out. When EDF schematics are imported, they're placed underneath our blocks category. You can right-click on the memory game v1_2 and set that as our root. Now we can see the different sheets within the memory game that were brought in through the EDF schematic. We can select sheet 1 and we can see our microcontroller, the AVR16EB20T. The output from Celis has preserved the logical design, including all the components and connections. One thing to keep in mind is that there's currently no physical library attached to our schematic. We'll need to find matching symbols, footprints, and 3D models. For this demo, we've pre-created library components. However, in your workflow, if you're recreating this with a different Celis design, you can use existing libraries, leverage PartQuest. If you're recreating this with a different Celis design, you can use existing libraries or leverage PartQuest. We'll see this later on in this demo, or you can create your own custom components. Celis has given us a solid starting point that we can make our way through optimization and refinement. As we all know from experience, no design ever stays static, whether it's performance requirements or supply chain issues forcing component changes or simulation, revealing opportunities for improvement. In developing the memory game, one of our more critical constraints was ensuring that the memory game is power efficient with low power consumption, so that all of you can continue playing with it over and over. Celis currently has our boost converter set to a 5-volt output, but is this truly optimal for our memory game? Our AVR microcontroller runs fine on lower voltages, and our LED lights don't need the full 5 volts. This is exactly where simulation can come in and help us make informed decisions. To demonstrate this, I'll show you a mock-up of how manufacturers might embed interactive circuits directly into their product pages, helping us throughout the design process. While this specific integration isn't available yet, it represents where the industry is heading. As mentioned, we want to investigate if 5 volts is the optimal output for our boost converter. Let's go to the MCP page. Let's go to the microchip product page to check out our boost converter. There is a lot of helpful information here, such as datasheet links, CAD models, and reference content. But what is really interesting is this interactive application example embedded right in the page. Here we can explore the key features as they apply to our specific memory game requirements. This example starts with a 1.5 volt alkaline battery and uses a feedback resistor divider to program a 3.3 volt output. But remember, our design uses a 3 volt lithium coin cell battery. Cell. And we're currently set for 5 volts to power our microcontroller and 4 LEDs. Now, coin cells have relatively high internal resistance even when fully charged, but our memory game shouldn't draw much current. Let me adjust these interactive design parameters to see if everything starts up correctly. The automatic PFM, or pulse frequency modulation, should give us the efficiency we need. After running a few virtual tests, I'm convinced this configuration will work. So let's push the orange button here to edit our own copy of the schematic in PartQuest Explorer. Perfect. Now we can actually modify components, not just parameters. This cloud-based simulation environment lets us customize the circuit to represent our actual memory game. Let's add a more detailed coin cell battery model that includes state of charge, dependent voltage, and internal resistance. We'll also add R4 LEDs and a test sequencer to simulate realistic operating conditions. So with this circuit, we can verify our controller will perform correctly under actual memory game conditions. So with this circuit, we can verify our controller will perform correctly under actual memory game conditions. Let's measure the average inductor current in steady state PFM operation using the measurement tool and waveform viewer. This tells us our expected battery life. Looking at the results, we're drawing 6.58 milliamps on average. That's actually a bit high for a coin cell. So let's try something. We'll reprogram the high side feedback resistor to 2.2 mega ohms. This drops our regulated output to 4 volts instead of 5. Running the simulation again, we can see that the average current is now 4.02 milliamps. That's nearly a 40% reduction in current draw. This means longer battery life and more time to play with your memory game. What's powerful here is the seamless workflow. From a manufacturer's product page straight into simulation with accurate models. And since it's all cloud-based, there's no software to install. Just open a browser and start optimizing. We've found our optimal output voltage, so let's head back to Expedition and swap in that 2.2 mega ohm resistor. Back in Expedition, we can see our boost converter. The feedback resistor we need to charge is R28, which is currently set to 3.09 mega ohms. Based on our simulation results, we want to change this to 2.2 so that our output voltage is set to 4 volts, lowering our overall power consumption. To do this, we'll go to the application launcher and select PartQuest Portal. PartQuest Portal has a comprehensive library of over 6 million components with associated ECAD models that we can bring directly into our design. We'll start with a descriptive search. I'll type in 2.2 mega ohm 1% resistor and hit search. Using the filters on the left-hand side, we can further refine our results. For the package size, I'll select 0402 to ensure that the footprint and layout stay the same. Based on our search, we have 232 available parts. At the top, we can see a Vishay Intertechnologies resistor that we'll use in our design. At the top, we can see a resistor that we can use in our design. I'll split the screen so I can see PartQuest Portal on the left and my design on the right. In Expedition, we'll need to open Project Explorer by hitting Ctrl F. I'll also consolidate my windows by holding and dragging to merge them. Project Explorer shows us the parts and symbols within our library, as well as parts and nets within our design. Going back to PartQuest Portal, I'll click the drag and drop icon. It will ask which partition I want to place. It will ask in which partition I want to place this part within my library. Based on the category, it has selected resistors for the partition. I'll hit save and exit, and this helps keep my library organized. Now I'll drag the part into my library. we can see it says drop here to import PartQuest parts. And when we let go, the PartQuest import starts bringing in all of the parametric and CAD data. Once the import is finished, we can use the search bar to filter for our part and confirm that it's been brought in. I'll maximize expedition and delete the existing R28. Then bring the new resistor into the schematic and place it. This is a great example of how the design process is transforming. We're able to quickly use online simulation to find the resistor value we need, then use an online library to quickly drag our resistor and drag it directly into our design, significantly speeding up the overall design process. We can also use PartQuest to find more information about our components. If we had doubts about our feedback resistor or wanted to look up the equation for the output voltage, we could go to PartQuest and type in our boost converter part number. Once we find it, we can use the Smart Datasheet feature. Smart Datasheet indexes the entire datasheet so you can see it. Smart Datasheet indexes the entire datasheet. You can see this process happening in the top right corner. Once indexed, AI-powered search is enabled, allowing us to ask questions in natural language. Once indexed, AI-powered search is enabled, allowing us to ask questions in natural language. For example, we can ask, what is the equation for the output voltage? And it will jump directly to that location in the datasheet while also providing the information in the chat. It will jump directly to the location in the datasheet while also providing the information in the chat. We can also ask, what feedback resistors will I need for 4-volt output? While it may not do the math calculation directly, it shows us the calculations for the adjustable output voltage, pointing us to equation 5-1. This is extremely useful, especially with large datasheets for FPGAs or microcontrollers. When you need to quickly find information and Control-F doesn't cut it, the AI-powered search helps translate your natural language question into specific datasheet locations, allowing you to interact and chat with the documentation. With the boost converter now optimized, there's another critical design consideration we need to address: supply chain reality. We all know that the best design can fail if we can't source the parts. Within our schematic capture tool, we can quickly enable the supply chain view by adding it within Project Explorer. From here, I'll update our supply chain data. We can see all the parts within our design with color-coded indicators. Green means parts are in stock with active lifecycle. Yellow, multiple or partial records found, and red means no units in stock or lifecycle issues. For yellow indicators, we can double-click to investigate. We might see multiple sources. For instances, both DigiKey and Mouser might have stock, but if one shows lifecycle as an A, we'd choose the one with confirmed active status. For red indicators, we can investigate alternative distributors or consider replacement parts. All this information is at your fingertips during the design phase. I remember early in my career working on an engine controller unit design that was broken into modular blocks. High side drives, low side drives, current monitors, etc. One of my tasks was to understand not just the overall design cost, but the cost per block and lifecycle status. I had to manually search for each component on DigiKey and other sources, eventually trying to write a script to pull the data. But that was all after the fact. I couldn't do it within the design itself. This is the transformation of an integrated workflow in action, from reactive scrambling to proactive decision-making, all within the design environment. I'm now able to see supply chain data while designing, catching issues before design review or even manufacturing. This allows us to make informed decisions and changes based on real supply chain constraints. In the typical design process, you would continue making changes to your design based on supply chain issues or other requirements. Once your schematic is ready, we can then push it to layout. Let's jump into layout and explore the design together. I've fast forwarded to a completed schematic. From within Expedition, we can go directly into layout by opening the application launcher and clicking on layout. This will launch the layout application. With layout open, we can now start exploring our design. Using display control, we can turn layers on and off. For this example, I'll turn off layers 1, 2, and 3, leaving only layer 4 visible. Here we can see the ground mesh placed directly beneath the touchpad to prevent accidental touch triggers. Here we can see the ground mesh placed directly beneath the touchpad to prevent accidental touch triggers. Both layout and schematic feature predicted commands. Those are commands based on your current usage patterns, and the tool predicts what command you're most likely to use next. It learns from how you actually work. This puts all of your most frequently used features just a click away. From within layout, we can also manage the constraints for our project. Going into integration and then constraint manager, we can set our rules based on net classes and clearances. We've entered our rules based on the manufacturing guidelines provided by our manufacturer. This ensures that during placement and routing, we'll be prevented from creating any violations based on our constraints and current settings. Layout also includes a 3D view, which is an excellent way to visualize the end design and check for mechanical clearances or component conflicts. Throughout this design process, I want to highlight the seamless integration between the tools. We've moved from AI-assisted circuit discovery through cloud-based tuning and simulation into schematic capture, and from schematic, we can quickly launch directly into our layout. Now we've completed the hardware, but a memory game without software is just an expensive coaster. We need software to bring this memory game to life. Optimizing touch sensing, implementing game logic, and managing power consumption. This is where Microchip's MP-Lab AI Coding Assistant comes into play. The MP-Lab AI Coding Assistant helps streamline development, improve software quality, enable rapid iteration of game logic, and lets developers focus on innovation rather than boilerplate code. Using these partner tools helps you to effectively develop, program, and debug embedded applications. Let's move on to the next step in our design process. With our schematic, layout, and software development complete, we're ready to share our design, whether for manufacturing, procurement, or colleague review. I remember my first design reviews. Zipping up design folders, uploading to file shares, sending emails to notify engineers, then tracking comments in Adobe PDFs, and the chaos of ensuring everyone had the correct version. It was quite a challenge to keep everything synchronized and ensure all feedback was properly addressed. Modern tools have transformed design reviews and collaboration entirely. Let's take our design into a cloud-based collaboration ecosystem and see how easy it is to 1. View and share designs, 2. Track revision history, and 3. Collaborate in real time. Let's head back to Expedition and upload our design to see these collaboration features in action. Now that we're back in Expedition, let's prepare our design for upload. Go to File, General, and click on Close. We need to close our design before we can upload it to the cloud. Once closed, click on Upload and navigate to the design folder. Select the project file and hit Open. Now we'll create a new project. Click on New Project and give it a name. For the description, I'll add memory game. Click Create and Upload to begin uploading the design to the cloud-based collaboration ecosystem. Click Create and Upload to begin uploading the design to the cloud-based collaboration ecosystem. This just takes a moment. Perfect. Our design has been uploaded. You can see it listed here. Notice we have the option to edit exclusive. This allows us to edit our design locally and check it back in when we're ready to save our changes. Let's go ahead and select that option. Now that we have our design checked out, let's explore the collaboration features. Go to Application Launcher and select Connect. Within Connect, you'll see our project. Click on it to open the collaboration workspace. Here we can view the design as a schematic. This interface allows us to add collaboration notes that can be shared with our entire team. What's great is that collaboration notes can also be added on both the 2D and 3D views of the layout. You're able to review the routing and layers, and since this is all browser-based, no standalone tools need to be installed. Let's switch to the 3D view. Here we can see our 3D models and board layout in stunning detail. This view really helps visualize the final product. Now let's take a look at our BOM. We have a consolidated BOM view here. One of the truly transformational aspects of this workflow is that supply chain information is at your fingertips at almost every step of the process. Within Expedition, you can see your BOM status. You have access to the supply chain data, allowing you to make quick changes while designing. Your team members in manufacturing and procurement can also access supply chain information using BOM Intelligence. Let's configure BOM Intelligence. We'll map our manufacturing part number and hit OK. Watch as the BOM status populates. It's analyzing each part in our BOM, finding associated risk, and gathering pricing information. On the left side, you'll see visual analytics showing part matching status, lifecycle information, and risk ratings. This is an extremely powerful tool for reviewing your BOM and making informed decisions. The platform also offers robust file sharing capabilities. You can add new users to your project, either internal team members or guest users. Then you can assign them specific permissions, admin, editor, or reviewer, giving you complete control over project access. In the History tab, we can track different versions of our design. Currently, we see version 1 with no added comments. Let's demonstrate the check-in process. When we close our design, we'll be prompted to check it in. If we close out Expedition, it will ask for a check-in message. Here we can add a descriptive message and notify our team members. After checking in, version 2 and its associated check-in comment will be displayed in the project history. This provides an excellent audit trail of changes and help teams track what modifications have been made throughout the collaboration process. Now that we've shared our design and had several team members review it, let's run a manufacturability analysis to ensure our design is ready for production. Before we continue, I should mention that both Connect, the collaboration platform we just used, and PCBflow, which you're about to see, are included with the Expedition license subscription, so you'll have access to everything we've demonstrated. Let's continue our design journey and verify that our memory game can actually be manufactured. To run our design for fabrication analysis, we click on Fabrication Analysis, prompting us to create a new project. I created a project and uploaded our ODB++ file. I also uploaded our BOM so we could run assembly analysis alongside the fabrication checks. The key step was selecting a DFM profile. These profiles contain the actual manufacturing rules from specific PCB fabricators or industry standards organizations. Each fab has different capabilities. For example, minimum trace widths, via sizes, and clearances. For example, minimum trace widths, via sizes, and clearances. These profiles ensure our design matches what they can actually build. For our memory game, we selected the PCB default DFM profile and ran the analysis. When the analysis is completed, the system performed hundreds of checks using Valor technology. Everything from trace width violations to acid traps to solder mask slivers. Real manufacturing issues that cause board failures. What I found particularly useful was the ability to share these results via email with anyone, even if they don't have a PCB Flow account. They receive a link to view the interactive results, which make it easy to work with our manufacturer to resolve any issues we find. Within the same project, we reviewed our BOM pricing information. Again, supply chain data followed us through the entire process. We can see the breakdown of our memory game BOM, including price per unit, minimum order quantities, estimated costs, and availability. When we needed a manufacturing quote, we used the built-in RFQ generator. We fill in the details that couldn't be extracted from the design files, quantities, lead times, and special requirements, and it generated a PDF we could send to manufacturers. The beauty of this being cloud-based was that there was no software to install. We uploaded our design, selected manufacturer's rules, and got instant feedback on whether our board could actually be built. It handled standard boards, flex, and rigid flex design with equal ease. With our DFM analysis complete and our design validated for manufacturing, we've reached the end of our design journey. Let's step back and look at what we've accomplished today. We took a simple idea, a battery-powered memory game, and transformed it into a manufacturer-ready design. We used AI to accelerate component selection, saving hours of manual research. We optimized power consumption by 40% through simulation before ever touching a prototype. We verified component availability at every step, avoiding those painful last-minute redesigns. Plus, we dragged components between applications, shared our progress with colleagues through the cloud, and watched our design flow seamlessly from schematic to layout to manufacturing checks. That's the transformation in action. What we've seen is how Siemens, Microchip, and Celis work together to transform the way we design. The tools predicted what we needed next, caught potential issues before they became problems, and handled the tedious stuff so we could focus on actually designing. This is what transformation looks like, not replacing your expertise, but removing the friction that keeps you from using it. To wrap up, Expedition brings together 3 core strengths that help you design, reuse, collaborate, and release to manufacturing faster. First, it keeps productivity flowing. You get seamless data continuity from concept through manufacturing, built-in constraints and automated checks to prevent errors early, and streamlined outputs that are ready for production. Whether your designs are simple or complex, the environment flexes with your needs so you never lose momentum. Second, Expedition is built for modern collaboration. The intuitive UX makes onboarding fast, while flexible collaboration, on-site or remote, lets teams work the way they prefer. Automated design changes and reuse reduce repetitive work and keep everyone aligned no matter where they are. And finally, intelligence is infused throughout the workflow. Global search and predictive commands accelerate everyday tasks. Real-time component intelligence reduces sourcing and supply chain risk, and actionable DFM insights help ensure your designs are right the first time. Together, these capabilities empower you to make faster, smarter, and more resilient design decisions. Ultimately, Expedition gives you the adaptability, integration, and intelligence needed to build world-class products with greater speed and confidence, no matter the size of your team or the complexity of your designs. Your license also includes on-demand training at no extra charge, support with Software Center access, self-paced training, and access to our community forum. We'll also be hosting more webinars on specific topics like library components, schematic design, layout, and new features as they're released. That brings us to the end of our webinar. Thank you everyone for your time, and I hope you have a great day. See you soon.